customers, welcome to our first Digital Competence Days 2021.
Thank you for joining us. We have 3 days here, a manual day, an automatic day, and a smart day. We'll start with a fully manual production. Let's go and see the machines. Hello, Torsten and Roland.
Hi, Gerrit.
Hello, Gerrit.
I see the new BySoft Cam on the screen behind me. What does it do for our customers?
Yeah, this is our new BySoft Cam, where we can program the machine, where we can use all the features from our laser cutting and bending machines.
All right.
So I would like to show you in a small demo how we will do that.
Okay. Roland is going to do that?
Yeah. Roland is going to do that.
Thank you, Roland.
So, Roland, I think one of the first steps we usually do when we have to program our machines is we need to have some parts. We need to have some 3D parts that we maybe get from our customers.
Yeah, of course. So a typical workflow is that we start with an assembly. So I will show how to treat an assembly with a new project in the auto part. So in here, I can directly open everything that is combined in the assembly. And BySoft Cam is then directly recognizing all the parts from that assembly and is bringing that to a list and showing us what type the parts are. Are they just for cutting or also for bending?
Okay, so here already a lot of parts are being loaded. So we see that everything looks fine, everything looks green. So we can cut and bend these parts now, or what do we need to do?
Not ready for cutting and bending, but just one more click and then BySoft Cam is automatically calculating cutting and bending technology for the part. So they are ready then for the process.
Okay, that sounds really good. So I just need 2 or 3 clicks to be ready for the machine.
Yeah, that's true.
But maybe let's have a deeper look on how that would be for a single part then.
Okay, so if you have just a single part, we directly open it in the part editor. So here again, it's a 3D file that I'm opening. Of course, it can also be a flat file like a DXF.
Sure.
But yeah, the part is recognized, and what the next step is, of course, is adding the technology. So to start, I go to the bending technology, and here, again, with one click, I can define everything completely. Of course, I could also work in a manual way and apply everything in a manual manner. But once again, automatic technology is what we most use.
Okay, so now it's calculating all the bending sequences and tool that it's required. Again, it looks everything green, so I'm already done.
Yes, basically, this is like a recommendation from the software according to my pre-settings, of course. But yeah, I can now directly check the simulation, which is the same simulation as on the press brake. And with that, I can check if I'm happy with that and directly export to the press brake.
Okay, that really sounds easy. And now, when we look to the cutting, what do I need to do there?
Well, of course, you need to produce the part physical. So that means we need also to apply cutting technology. The cutting technology is also one click more. So we apply the cutting technology automatically. Yeah, and also now the part is ready for cutting.
Okay, and here I also see directly how it would then cut the part.
Yes, cutting sequence, lead-ins, everything is here.
Okay. That really sounds easy.
It is.
you even not one time touched the keyboard, so you could do everything with a mouse click.
No.
That really is easy. So in a typical production, then now you would combine different customer assemblies, different parts that you want to cut together in a bending, in a nesting.
Yeah, in a nesting for cutting.
Okay.
Yeah.
But I think we would skip that step today, and therefore would have a look more to the chip machine and how we would program the tube in a similar, easy way.
Okay.
Okay. Thank you, Roland. Hello, Georgia.
Hi.
Now we want to have a look at the tube master and want to see how the workflow is to create the software for the tube.
Okay, so we can open the main page of the software.
Yes.
Yeah.
And I think the first step would be just to open an assembly of a part and
You're
to
right.
see how to do
So
that.
what we can do, in the main page, we can open the assembly that we want to produce inside the Tube Designer. So here we go, our assembly. So what we can do, we can process as it is without any problem, or if you can notice here, we have 4 parts that are quite similar. So in order to help the operator to not make any kind of mistake, we can tell to the software to join those 4 parts in one single tube. So in this
Okay.
way, we have just one part. We cannot make any kind of mistake. So then we have to straight this tube in order to let the software to analyze the angle and pick the correct faults. So what will happen during this unfolding is that on the machine, this part will have just one single part, then the operator on the machine can just bend it. In this
Okay.
way, we have one part with not 4 parts to find the correct position.
Okay, so just load one tube and that's it for that part.
Exactly.
Okay.
But if we go back again on our assembly, as you can see here, we'll also improve a little bit our assembly. Look here, we have 2 parts that are quite similar, so we can make the operator again a mistake. So what we can do also is to recognize those 2 parts and perform a connection. What is a connection? It's a male and female on this part where we can tell to the software the exactly position of the part to pick the correct position and also to recognize the correct part that we want to use, to not make any kind of mistake. See here, you see that we have a male and female connection directly applied on both parts.
So that would be like plug and play in the end, right?
Exactly. We have finished, basically.
Okay. So what would be the next step then?
Next step is to save this assembly, and in background we'll also save the technology and pick all the parts inside a nesting.
Okay.
So if we go back to our main page here, we already create a nesting with inside the parts of our assembly, the quantity. We can insert the format, so which stock we have available on our row bar, and then the software will create a nesting. What's a nesting? It's basically all the parts inside the row bar. In this way, the software will optimize all the row bar in order to have a correct solution. We can open that one inside our machine. Look, as you can see here, the part has been rotated in order to optimize the space and the time. The next step is to generate the simulation. And
Let me see how that looks like, that simulation.
so you see, in the simulation, the software will reproduce exactly what will happen on the machine. And if everything will fine and this indicator remain green, means we can go on the machine and save the NC file. The NC file is the output what the operator will use it to cut this part. And in case if we have an error, one of these indicators became red, the simulation will be stopped, and then we have to analyze the problem.
Okay, and then you just can manually optimize.
Adjust
all
the
this-
problem.
adjust the
Exactly.
clocks.
So now the simulation has been finished, we can save the NC file to the operator. But sometimes the operator doesn't know which part are inside the programming. He is not the operator of the software. So we can give to them an additional information with the PDF file.
Okay. So with that additional information, he has then all the information and can link it to the NC file, right?
Yeah,
What's
we have
inside
the
there?
feedback. We have all the part detail list, the quantity, and his cutting time. So the operator can check which part has been produced on the machine and his cutting time.
It's like a structure and like an explanation for the operator. So
Exactly.
very easy to execute then.
So we have finished. We have the NC file, we have the PDF file. What's next?
I think we have to go to the machine then.
Yeah, you will see directly
Okay.
the unfolding and the connection that I show you directly in this software.
Okay, thank you, Georgia.
Thank you, Georgia. Thank you, Torsten. Let's go to the tube laser and see this for real. It looked very easy.
Yeah.
It
All right.
is, Gary.
Hi, Davide.
Hi Gerrit, how are you?
I'm fine. We're standing in front of a new tube laser, I see.
Yes, that's a new tube laser, the ByStar 130.
I hear it's pretty complex, a machine like that.
Yeah, tube laser processing is difficult in general, but the difficult task is to make customers happy. They're very demanding. They want all the time the very high precision, the flexibility, the accuracy, the speed, all together in one machine.
In one machine.
Yes.
And we can do this.
I think we made it.
Okay, can you
Let
show
me
me?
tell- Yes,
Yeah,
I
let
will
me
tell
show
you
you.
short.
Okay.
First, we improved the flexibility,
Yep.
adding open section capacity to the existing BT130.
Is that a tube which is open, like a U?
Yes, you have closed section and you have the open section like Engels and U.
All right.
On top of that, we improved the accuracy, adding the laser scan to the package.
Yeah.
And either you use the quick cut is another option with in the quality mode to increase the quality of the cut, or in the performance mode to increase the speed.
You can go really fast.
We can go really fast.
Okay, show me.
Yes, I will show
Okay.
you the detail.
Yeah.
Let's start from here. So like I said, on the ByStar 130, we added the open sections capacity. It means on top of the existing cutting range from 10 to under 30 millimeter round, square, rectangular tubing, we now have also the open sections. I mean, this machine can process angles, can process flat parts, can process channels, UPN, UPE, and in mild steel, aluminum, stainless steel. And the big benefit is that moving from closed sections to open sections requires no setup by the operator. So this machine is fully automatic. You can easily go from closed to open sections without changing anything. This means more time for cutting parts, less downtime for setting up, and this is, of course, beneficial for the customer. So this is increasing a lot the flexibility of the machine, and this makes the ByStar 130 more suitable also for job shops and service centers. But that's not only this. On this machine, we have improved a lot the accessibility to the loading area for the manual loading and to the cutting unit for the maintenance of the cutting head, for example. So this is the new design, new housing with better accessibility. And then let's start with the cutting process. Nicola?
Great, so we will close the door and we can start our cutting process. Okay, now the cutting process is starting. Everything starts from the back, and we will have the machine automatically load any kind of tube from the back of the machine. So you will see the fully automatic system load all the sections. So everything will drop down on these white chains, and then the fully automatic system will bring every tube in the measuring area, and the machine will automatically sort tube by tube. It will measure the tube, and then we will have a fully automatic system that will bring our tubes inside our machine. Once the tube is inside our machine, we will also see some other important features about this machine. So the next step will be watching inside and see what this machine can offer to our customers. Now we're waiting for our tube inside. Once the tube will reach the mandrel number 2, it will be inside the chuck. The chuck will close and we will see a red light. This red light is called weld seam camera, like you see. It will detect the weld seam on the tube, and according to the weld position, we will have all the holes and all the cuttings well positioned in our tube. Another important feature inside this machine is called laser scan. So we have those two silver boxes on the sides of our tube, and this system is scanning with two laser beams the tube shape, and according to tube shape and tube bending, we will position the head exactly in the center of the tube. So it will compensate the bending of the tube, and it will always guarantee us 0.2 millimeters of tolerance during the whole system. All the procedure will be completely automatic, so you don't need to do anything. The third very important thing about this machine is called quick cut. What is the quick cut? So the quality quick cut is a feature that allows us to have much better quality, much better cutting stability, and it consists in X movement, so the head will move instead of the tube. It will guarantee no vibrations on the tube, and the head have a 30 millimeter path where it can move along the tube, just keeping the tube still and improving our cutting quality.
And not only this, so sweet cut that, like Nicola said, is the possibility to travel the head on the tube for 30 millimeter. We can either achieve high quality by moving the tube only with the tube, the head wall only with the tube still, or we can interpolate head and tube together to achieve a much higher cutting speed, up to 50% in the best condition. This is the quick cut in the so-called performance mode.
Great. Now we will see a few parts with all our technology, and we will also show you why we are choosing the tube laser for our customers, because what you can do with the tube laser is to improve your cutting time, reduce your cutting and waste of time. And now I will show you one very interesting thing. So instead of cutting 4 parts, I will show you how you can build a frame with just 1 part. So in this case, we have got this long bar. I have removed the scraps they were joining, and now I will show you how easy it is to make a frame from this part of tube. So Garrett, do you want to try it and show?
I'll try this. I love bending, so I just go like this. Wow. I feel like Superman.
You are so strong,
and
Garrett.
quite tired, so I'm going to sit down. Thank you for watching the tube laser, and let's go to the flatbed lasers. Hi, Michael.
Hello, Gerrit.
Hello, Yves.
Hi,
We're standing in front of the new BySmart fiber, 10 kilowatt. Can you show us some of the new features?
Sure, yes. So as you might know, we will here present 2 different machines as well as different technologies. I mean, to meet our customers' expectations of productivity, reliability, and flexibility, we are going to focus on 2 machines, technologies, and as well on different cutting gas technologies.
Okay.
So as you might know, for the productivity, you will see, of course, then also the ByStar fiber 15 kilowatt, so high power, as well as some new features that help further increase the productivity. For example, fast piercing and a feature called intelligent cutting process.
All right.
And also, to get the full benefit of this productivity, you need a stable and reliable cutting process. Again, there we have features that monitor the cutting process and help get full benefit of this.
Exciting.
And last but not least, for flexibility, we of course can cut a lot of different materials, different thicknesses, and we will also show some different cutting gas technologies will also help to get this kind of flexibility. Now, we will now start with the BySmart fiber 10 kilowatt, right here. And as mentioned, here we will also focus on a different cutting gas technology. In this case, shop air cutting, so we will cut with compressed air. And you know, compressed air you can produce by yourself with a compressor and booster.
Yeah.
This means you're a bit more independent from gas suppliers.
Okay.
You can as well then also reduce the cost per part, as well as increase the feed rate, especially when cutting aluminium. You will see this later on. But I would say enough talking. Let's go over to Yves and see some actual cutting.
Yes, let's do that. We start straight away inside the machine. We're cutting at the moment 2 millimeter mild steel with compressed air. So as you can see, it's extremely fast. We're cutting here at a speed of 48 meters per minute. At the moment, what you can see is some separation cuts on the small contours and as well on the big contours. The idea of that is that we can avoid collisions and micro joints. So what you don't want to do is to have micro joints because it will let you mark, and you don't want to have as well your parts to flip over. So that's why we separate this. Our software is doing this, of course, completely automatically. This part that we are cutting right now is actually the part that we are using in our recycling bin. That's the top of our recycling bin. On this part that we are going to see now, we are doing again separation cut to show you some different technologies, as well to avoid collisions, to have a safe process. Overall, shop air, compressed air can be used in aluminum and stainless steel up to 30 millimeters, in mild steel up to 12 millimeters. So extreme fast piercing. In this case here, we're a little bit faster than with nitrogen. Those small holes are cut about 9 holes per second. Here, what you see is the scanning. The scanning is helping to reduce the cutting time and especially to avoid collisions. So in this process, there's no chance that one part will flip up and produce a collision to our cutting. So that's actually the part that we are cutting right now. That's those small holes that we can see. Our scanning here, no problem because we have all the separation cuts on those contours. We're going to start the next plan, which is a 10mm aluminum, as well, of course, with shop air, compressed air. So we're going to first see our collimation changer, which means we are changing automatically the focal length because it's a different thickness, different material. We don't need to tell the machine what to do. Everything is happening fully automatically. So as well, we are changing the nozzle tip. So depending on the material, the gas, and the thickness, we have different nozzles. This machine here is equipped with 40 different nozzles. At the moment, we are doing calibration to make sure that the nozzle distance is always perfectly set. So now we have the detection eye, which is our camera system that detected the sheet within 6 seconds, which is actually a new feature on the BySmart fiber. So we're even faster and more proactive. So in aluminum, with shop air, compressed air, we're, depending the thickness, up to 60–70% faster than with nitrogen. This actual part that we're cutting now is 60% faster with compressed air than with nitrogen. Perfect edge quality and nearly no burr. So it's a big improvement compared to nitrogen. Last, on this machine, we are not going to cut this part, but the last part we're going to have a look at it is a 20mm mild steel. We cut this part on 10 kilowatt normally with oxygen. That's the fastest and most economical process for this machine. We would cut this in 2.5 minutes. We will cut the same part later on the 15 kilowatt, and we'll see what times we achieve there.
We're in front of our ByStar fiber, 15 kilowatt, right?
Correct, yes.
15 kilowatt. There's a couple of new development here. I even heard talk about artificial intelligence. Is that true?
Exactly, yes. So
but that's, yeah, one of the features probably.
yes, we have a few. So we are at our benchmark machine, ByStar fiber 15 kilowatt, so highest laser power. And we'll also show a few different technologies and features. What we are going to focus here is on cutting with mixed gas. So over at the BySmart fiber, we have seen cutting with compressed air. Here the focus is on mixed gas.
All right.
Now, when you mention features, so we also have a feature to further increase the productivity. It's called fast piercing, so an improved piercing process. We have as well a monitoring feature. The intelligent cutting process is basically a camera which takes a look through the cutting head into the cutting process.
Through the lens?
Yes.
All right.
And last but not least, we also have a feature called parameter tuning, where you have, in a matter of a few minutes, the perfect parameter.
And that's the intelligent part?
Exactly, yes.
All right, I'd like to see that.
Yes, so then let's see some action and cut some parts.
Okay.
So we will start on this 15 kilowatt with a 10mm mild steel. So this is not a regular mild steel. It is a very low quality mild steel, so no laser material. We'll cut that part with mixed gas, which means we take nitrogen, add a little bit of oxygen to it. Like this, we are going to save time. We're about 15% faster than with regular nitrogen on this part here. And we have a perfect quality, although it's a low quality material. The next feature we're going to see on this part is our fast piercing on all those holes. The piercing time will be like 0. And the third feature is our ICP, our intelligent cutting process. So the intelligent cutting process is a camera that is watching through our cut inside the material. And as soon as we have a problem with the cut, the machine will stop, go back, and restart the cutting. That's the first feature. The second feature is we start with 95% of the time, of the speed, sorry, and we speed up until we have a tear off, which means our cut is stopping. Our machine will stop, go back, and continue the cut with 5% slower than the maximum. Like this, we're always on the limit, and we go to the maximum of the speed with a safe process. The last function is the controlling of the nozzle tip, the nozzle body, collisions. So as soon as we have a collision, we lose the nozzle body or we lose the nozzle tip, we will stop the cutting process. Now, let's cut this part. So we'll start with some engraving of the part to mark the part. Then you will see the fast piercing, with it extremely fast. The piercing time is literally like 0. So now that we are on the straight line, you can see we stopped. That's because the speed ramped up to 115% in this case here. The ICP realized it, reduced 5% and continued to cut the part. Which means we cut this part with 110% of the nominal speed. So now we take out the part, perfect quality in maximum speed. You can see here the edge is becoming black. That's because of the mixed gas, because we add a little bit of oxygen. But it's not the same oxidation that we have on oxygen cutting, which means you can weld and paint it without any problem. This part here, by the way, has been cut with 8.4 meters per minute. So, as Michael just said before, we have a new option that is called parameter tuning. So the parameter tuning is a tool that we are developing for employees with little experience or no experience for unknown material. The only thing what the operator does is pressing the start button. After that, everything is happening full automatically, which means we are cutting 5 parts with 5 different parameters. We're labeling the part, so you have a number on it. The only thing what the operator has to do is to remove the parts, look at them, and decide which part is the best, which part is the second, third, and so on. Of course, we don't need to label all of them. If we decide one is really bad, we don't need even to rate it. But the more we rate, or the more accurate we rate, the better the artificial intelligence is going to calculate the next parts. So after the first 5 parts, we generate automatically a parameter set for the next 5 parts. We cut them, do exactly the same. We take them out, we control them. So the idea is that the latest, after 5 rows, sometimes 3 rows are enough, we have a good part or a satisfying result. So as soon as we are happy, we'll press on finish. At the end, of course, there's just 2 parts. I really decide which one is my absolute favorite. We generate automatically the parameter that we will label accordingly. And as you can see, within a very short time, we have from an unacceptable result to a good result. So, next, I want to show you another part. That's 20 millimeter mild steel. Maybe you might remember on the BySmart fiber, we showed you this part. There it took 2 minutes, 32 seconds with oxygen. On this 15 kilowatt with mixed gas, the same part takes us 1 minute and 3 seconds. So it's a lot faster. You can see, same edge as on the 10 millimeter, it's a little bit oxidated, but we don't need to remove this oxidation. That's the big advantage. Instead, we have a little bit of burr. It's not perfect like with oxygen on the bottom, but weldable and paintable without rework on this, and much faster. The big advantage as well is we're going to cut the same part in sandblasted material, in hot rolled material, in rusty material, it doesn't matter. We're always going to get quite a similar result with a similar parameter, and that's a big plus. So let's cut that part. So as you can see, the piercing is like 0. It's not actually really 0, it's 0.3 seconds. But that's incredibly fast for 20 millimeter mild steel. And we have here a maximum cutting speed of 2.3 meters. A standard oxygen cutting would be about 1 meter. So it's a lot faster. So now I'm very curious to see how that part looks like when we take it out. So you see I'm wearing my gloves. It means the part is getting warm, of course, but it's getting much less warm with mixed gas than with oxygen, which means we have no heat issue. With oxygen cutting, as soon as we have too much heat, we will have a problem cutting. With the mixed gas, we avoid that problem. So it means we could cut a lot of small parts with a lot of small contours, small holes, full sheet without any single trouble. So let's see the part. So as you can see, it's a very bad quality material. On the back, all the rust as well here. This is actually not a laser sheet, this as well is a plasma sheet. The black edge, as I said before, we have a little bit of burrs. But we are a lot faster and we don't need to rework the sides.
Thank you, viewers, for your interest in our fiber lasers. Thank you, Yves. Thank you, Michael. Our next topic will be our press brakes. Hi, Sebastian.
Hi.
We're standing in front of our Xpress 80. When I look at this machine, simple and economic springs into my mind. Sebastian, can you explain everything about this machine?
Of course. This machine is available in 60 up to 160 tons, and this right now is a 2-meter machine, and it is for simple producing bend parts. So above all, this machine fits perfectly if you need a machine 1 or 2 times a day, and therefore it is a simple and clever working with this machine. So you have the same control as at every other bending machine from Bystronic, so it's easily to program and to using this machine, of course. So your operator need only one training at our bending machines, and then he can transfer the knowledge to all other bending machines. And you see, parts will also be possible to bend in a good quality, and above all for small batches, this machine will fit perfectly.
Okay, thank you, Uli. We'll hand over to our Xpert Pro, the state-of-the-art machine, and this Xpert Pro even has a modular tool changer attached to it. Thank you. Hi, Sebastian.
Hi, Garrett.
Is this the new Xpert Pro 150?
Yes, I will see.
And this one has a modular tool changer attached to it?
Of course.
And a lot of other new features?
Yes.
And you're going to explain everything about it?
I hope so.
And Thomas is going to help us bend?
Yes.
All right, let's go.
Thanks. So, in the back we see our Xpert Pro 150. This machine is a really high, flexible, fast and precise machine. So, this machine will be available up to 320 tons by 4 meter bending length. And the cool thing about our Xpert Pro is it doesn't matter if you have more stations or bend over the completely bending length, you will have always the same quality in your angles. And this we will guarantee by our dynamic grounding system, what is sitting in the middle of the lower beam. And this machine is really fast because we can, with our Xpert Pro, bend up to 20 millimeters with up to 20 millimeters of bending speed. So above small batches, we can bend in a really fast way and, of course, precise way. And the Xpert Pro has in the back right now a modular tool changer. And why is this tool changer in the back? Because this work is approximate 70% of the operator's job, but the rest of the 30%, of the approx 30%, are non-productive times. These times are bringing the part to the next value chain process, bring parts for the next bending job to the tool changer, to the Xpert Pro, and of course handling tools. And to automatically this, with our modular tool changer, this will be possible. So we completely automated the tool changing process that non-productive times come productively. And the great thing about our tool changer is it is also very flexible. We can store up to 52 meters of tools in our tool shelves in our tool changer. And right now, Thomas can bring the batches he bends right now to the next process area. In this time, will the tool changer change the tools automatically, and this will go really easy. So we are more efficient, we are more flexible, and of course, our operator has not to handle up to 1 tons of tools a day manually. And our tool changer is also really intelligent, because if he knows or sees, okay, he needs tools from the current tool setup plan in our next setup plan, then the tool changer will replace the tools in our climbing system directly. This function we call smart routing, and with this we save a lot of tool changing times with our tool changer. And also we are really flexible in the tools themselves, because with our tool changer we can handle tools up to V120, so you can store really big tools in and really big segments in our tool changer. Also, segments up to 550 millimeters of length are no problem for our tool changer as well. And you see, right now, it takes the tools, bring it to the next station, and it will go really easy and fast. As you saw, the tool changing process was really fast and automatically. And right now, Thomas could bring the last parts in the next value chain process and can start with the next bend part directly. And Garrett mentioned it already, we have also created other features and new features at our Xpert Pro. One of them is our new version of laser angle measuring system. With this system, we guarantee that you have with the first bend a good bend. And it is also really fast. You have not more time losses in bending the parts with our laser angle measuring system. Because we change the color of the laser from red into blue, and with this we are no more influenced by the circumstances in the environment. So we are more process safe, and also the cycle times of the measurement are faster than before. Also, you can measure right now really thick parts up to a V of 200. So we have right now 7 steps, and you can see it is a really fast and precise process that you can bend small batches or batches in a really precise way. And also, we have 3 modes in with our laser angle measuring system. The mode you will see here is an active spring back measurement, and with this measurement you compensate differences in your material life, because we measured the spring back in this moment where we bend the part. And you see right now the process is already done, and with our laser angle measuring system we have no time losses in the speed of the machine. Also, we have at our machine, of course, some bending aids, and you see, of course, our safety system, our motorized safety system, FastBend Plus. The Xpert Pro is a highly fast and precise machine.
Thank you, Thomas. We'll see each other in a minute. We're going to bend some other parts on our new ByStar. See you in a minute. Hello. We're standing right in front of a completely new member of our press brake family, a ByStar. A ByStar is a very fast machine. It's also a showcase. That means that you cannot buy this yet. You have to wait a little bit. Sebastian is going to explain you why you have to wait a little bit and why you want to buy it. Have fun.
What you can get, it is a machine with 120 tons of pressing force and 2 meter bending length. So you will be able to bend parts, bend jobs with up to 6 millimeter material thickness over the complete bending length. So you're really flexible, really fast, and really precise as well with this machine. And this machine is a really speed monster. So today it is a 2-axis back-edge system in the back, but this machine will also be available with a 6-axis back-edge system. So for highly flexibility. And we can bend with up to 30 millimeters per second bending speed parts. So if you have small batches, it is perfectly to bend this in a really fast way. And you see, this was really quick. And beside speed, quality is always a big issue today. So this machine will also be available with a laser angle measuring system. And we have created another great features. So for example, a tool shelf directly at the machine. You can store up to 5 meters of tools directly in front. We have optical bend guiding system in the upper and lower beam, and we have a motorized safety system, so you have not to add and adapt manually your safety system. And if you bend bigger parts, then we have some bending aids to support in the best way our and your operator.
I hope you enjoyed all that. Thank you. See you soon.
Thanks.
Today you saw how we can use our machines manually. Tomorrow we will show you how our machines can be used in a full automated mode. Thank you for joining us, and I hope I see you tomorrow.